Now we turn to the call stack in memory. Let us see where these frames really live while the recursion runs. Here is the chain of calls we are about to watch. Factorial of 3 calls factorial of 2. Factorial of 2 calls factorial of 1. Factorial of 1 calls factorial of 0. And factorial of 0 is the base case, so it stops there. Each call pushes a frame onto the stack. Each return pops one frame off and hands a value up to the caller that was waiting for it. In our picture, the stack grows toward lower addresses. That is a common convention on real machines. But C does not guarantee it, so do not rely on the direction. Let's watch the call stack, one frame at a time. The program starts in main, which calls factorial of 3. Main sits at the top and waits for the result. Factorial of 3 gets its own frame, pushed below main at a lower address. It holds n is equal to 3, and it is waiting on 3 times factorial of 2. Factorial of 2 is called. A new frame is pushed, even lower. It holds n is equal to 2, and it waits on 2 times factorial of 1. The frame for factorial of 3 is still there, still waiting. Factorial of 1 is called. Another frame is pushed. It holds n is equal to 1, and it waits on 1 times factorial of 0. Factorial of 0 is called. This is the deepest frame. Now the stack has 4 factorial frames plus main. Factorial of 0 is the base case. N is 0, so it returns 1 right away, with no new call. This is the first event in our return log on the right. That one goes up to factorial of 1. Its frame is popped. Factorial of 1 now computes 1 times 1, which is 1, and returns 1. That one goes up to factorial of 2. Its frame is popped. Factorial of 2 computes 2 times 1, which is 2, and returns 2. That 2 goes up to factorial of 3. Its frame is popped. Factorial of 3 computes 3 times 2, which is 6, and returns 6. Main receives 6. Every factorial frame is now gone. 4 calls going down, 4 answers coming back up, each answer used by the very next frame. Let us name the shape we just saw. Recursion has 2 phases. The stack grows, then it shrinks. Let us look at each part. First, the descending phase. Each call pushes a new frame at a lower address. The stack gets deeper. It stops at the base case. This is the deepest point. Here no new frame is added. Then the unwinding phase. Each return pops its frame and hands a value up to the caller. This whole chapter is one memory picture. Push on the way down, then pop on the way up. In Chapter 6, you saw push and pop for a stack you built yourself. Recursion is the same idea, but now the runtime pushes and pops the frames for you on every call and every return. Now a quick check. In the trace above, which factorial frame is freed first and which is freed last? Pause and think. Now the answer. Factorial of 0, the base case, was pushed last, so it frees first. Factorial of 3 was pushed first, so it frees last. Frames pop in the reverse order they were pushed. That is last in, first out. Your turn. You just watched factorial of 3. Now predict the next size up. Picture a pad of sticky notes. Each call adds a new note on top. Each return takes the top note off. You cannot touch a lower note until the notes above it come off. Look at the chain of calls. Factorial of 4 calls factorial of 3, which calls factorial of 2, which calls factorial of 1, which calls factorial of 0, the base case. First question. At the deepest point, how many notes are stacked? How many frames are alive at the same time? Do not forget the base frame. Second question. In what order do the values come back? Which one returns first and which one returns last? Pause the video and make a guess for both questions. Now the answer. 5 frames are alive at once from factorial of 4 down to factorial of 0. The values return deepest first. 1 from factorial of 0, then 1 from factorial of 1, then 2, then 6, then 24. The last note added is the first taken off. That is last in, first out, the same rule as the stack in chapter 6.